Namaste. I, Devi Smritika Chatwal, Faculty of Pharmaceutical Sciences in Jyoti Vidyapeeth Women's University, Jaipur, is here to deliver the lecture on course Dispersion, which comes under Physical Pharmaceutics 2nd, Unit 3rd. Now, today's our topic is coarse dispersion. Coarse dispersion, and what is coarse dispersion? It is a heterogeneous dispersion system in which the size of dispersed particles ranges from 1 micrometer to 100 micrometer. Mainly, it is of two types, suspension and emulsion. Suspension and emulsion we studied in first part of B Farm and first year of B Farm, right? Now, in suspension, what is suspension? It is a biphasic liquid system. And you know what is biphasic? In which two phases are visible, right? And what is monophasic? In which only one phase are visible. That I studied earlier in many topics, suspension and emulsion, right? So it is a biphasic dosage form of medicament in which the finely divided solid particles ranging from 0.5 to 5 micron are uniformly dispersed in liquid medium. Now, what is the size range of the particles of suspension? It is 0.5 to 5 micron. And the size range or size of the particles in suspension are very important criteria because this will give an MCQ question to analyze what is the size, right? So many times anyone can ask what is the size range of suspension particles, right? So you have to answer it like 0.5 to 5 micron, right? Okay. Now they are uniformly dispersed in liquid medium. Solid particles or liquid particles constitute dispersed phase and continuous phase. In suspension, solid particles constitute dispersed phase, and where liquid medium constitute what continuous phase. And in emulsion, we said solid particles are not there. It is of liquid particles or liquid medium. Liquid medium constitute to dispersed phase, and liquid medium also constitute to this continuous phase, right? But in suspension, solid particle constitute dispersed phase only, right? Now, what are the ideal qualities of suspension? The dispersed particles should not settle readily, and the settled particles should redisperse immediately on shaking. We know in many pharmaceutical suspensions, like for example ophthalmic suspension, which are present in market, they labeled as shake well before use, right? And many other suspensions, for example, bottles or suspensions for children, they also refer in reference or label that they stated as shake well before use. So firstly, you have to shake the bottle to uniform the dose or suspend the particles which gets slowly distributed or dispersed in between or bottom. Okay, the particles should not form a cake on settling, right? The particles of suspension should never form a cake on settling. They should be in a redispersed form. Okay, it should be chemically stable. The suspension should be chemically stable by its shelf life. If its shelf life is 2.5 months, so it should be chemically stable for 2.5 months. Okay, now it should be viscous enough to allow its easy pouring. If we pouring any suspension, then it should be easily poured due to its sufficient viscosity. It should be free from grittiness. Grittiness should not be there in any dosage form or any suspension, because suspensions are generally for external and internal applications. So grittiness is not allowed in it, right? It should have pleasant odor. The smell should be nice because if pharma if these properties are good, then everybody can take this. And if these properties are nice, then the market value of the product will be higher. and the product is purchased by many of the persons, many of the people, right? Now, so pleasant, it should possess pleasant odor, color, and palatability also. It should be stable in case of microbial attack too, right? No microbe can attack this product. So these are the ideal properties of any suspension. Now, what is the classification of suspension? Suspensions are classified in various types. They are, firstly, they are, if they are classified on the basis of general classes, the first one we consider is oral suspension. These are meant for oral administration, in which one or more insoluble medicament are dispersed in the liquid vehicle. For example, paracetamol suspension, which is available readily in the markets, right? Now, this is the oral suspensions. So it goes in the category of internal application, right? But if we consider external, so the other categories, externally applied suspensions. These are meant for topical application. Major person take calamine lotion, which is very common in generally, right? Calamine lotion is everywhere, in the market, right? Now, the third category we take is parental suspensions. These are heterogeneous system in which the solid phase is dispersed within a liquid phase. For example, insulin zinc suspension, this comes under parenteral suspension, and this parenteral suspension is also a category of what, internal suspension, because it goes through inside the fluid or blood, right? Because it is parenteral. On the basis of properties of solids, first category is dilute suspension. These comprise of solid constituents 2 to 10% weighed by volume, right? So, for example, in dilute suspension, cortisone acetate and prednisolone acetate suspensions are available. And in concentrated solution suspensions, these comprise of solid constitutes in concentration as high as 50% weight by volume. In For this, examples are there: external application of zinc oxide suspension and parenteral application of procaine penicillin G suspension. And now, on the basis of nature and behavior of solids, the suspension can be categorized in two categories. The first one is flocculated suspension, and the other one is deflocculated suspension. And flocculated suspension and deflocculated suspensions are both studied previously in B Farm first year, right? But here we go through with a short note about these flocculated suspension and deflocculated suspension. Now, what is flocculated suspension? These are the suspension in which particles have undergone flocculation, right? The particles make floccules. They aggregated with each other and form floccules, right? Now, what is deflocculated suspension? These are the suspension in which no flocculation has taken place, where the molecules or the particles or suspensions of dispersed phase will not go together. Okay, that is deflocculated suspension. Now, the other categories on the basis of size of solid particles. The suspension can be categorized in different categories. The first one is colloidal suspension, in which the particle size is below 1 micron, and in coarse suspension, the particle size is higher than 1 micron. And the third one, which comes under nano suspension, in this particle size ranges from 10 nanometer, right? Now, what are the interfacial properties of suspension? Two important interfacial properties of suspension are, the first one is the surface free energy and second one is the presence of electric charges on the surface of dispersed particle, that is known as surface potential. Surface free energy is when the formulation of suspension work is done to reduce the particle size, which leads to increase in the surface area of particle, which is associated with a excess of surface free energy. This surface free energy makes the system thermodynamically unstable. In order to increase the stability, particles flocculate and form light, fluffy conglomerates or form aggregates, which are held together by weak van der Waals forces. The increase in force energy due to reduction of particle size is given by the following equation, which is um, theta g is directly proportional to delta A, right? Where delta G is change in surface free energy, delta A is change in surface area of solid particles, right? Okay. Now the interfacial tension can be reduced by adding wetting agent. Wetting agent can also be called as what? Surfactant. And what in previous classes I suggested a surfactant which is most commonly used. That is what? Surfactant sodium lauryl sulfate. That is SLS. Or any other example is lecithin, which adsorb on the surface of particle or at the interface, right? Now, surface potential. What is surface potential? Surface, the forces at particle surface influences the degree of flocculation and agglomeration in a suspension. Force of attraction arises from van der Waals forces. Force of repulsion results from the interaction of electrical double layers surrounding each particle. The ionic species present in the solution get adsorbed at the surface due to ionization. Charges on the surface may arise. The surface charge will influence the distribution of ion in aqueous medium surrounding the solid particle. This produces the formation of electrical double layer. And when this electrical double layer is formed, when the surface charge is negative, then there will be layer of tightly bound solvent molecule called turned layer, whereas the layer of positive countries adjacent into the surface called diffuse layer. When the repulsive energy is high, it prevents collision of particles and they remain deflocculated, right? When deflocculated particles settle, they form closed packing. Okay, now we study reason for the formulation of a pharmaceutical suspension. The drug is insoluble in delivery vehicle to mask the bitter taste of the drug, to increase drug stability, and to achieve controlled or sustained drug release. We prepare pharmaceutical suspension. Ideally, the internal phase should be dispersed uniformly within the dispersion medium and should not sediment during storage. Right? These are the ideal properties of uh, uh, of pharmaceutical suspension, which we studied earlier. Right? Now, thus, in order to minimize the free energy, the system tends to decrease the surface area, which is achieved by formulation of agglomeration. Formulation of pharmaceutical suspensions require a knowledge of the properties of both the dispersed phase and the dispersion medium. If we are preparing anything, we have major knowledge of that system, right? So, if we are preparing pharmaceutical suspension, so in this, both dispersed phase and dispersion medium are there. So we have to take the knowledge of what? Dispersed phase and dispersion medium too. Now, the nature of suspended material, the interfacial properties of suspended material are an important consideration during the formulation of a suspension. So, what is the nature of suspended material or particle is very much considered. Particles that have low interfacial tension are easily wetted by water. So, we should take particles of what? low interfacial tensions and therefore can be suspended easily. Particles of materials with high interfacial tension are not easily wetted. The suspension of such material is normally achieved by using surfactants. For example, we know already surfactant is SLS or lecithin. A surfactant increases wettability of the particles by reducing their surface tension. And the second one is size of suspended particles. By reducing the size of suspended particle, it leads to decrease the rate of sedimentation of suspended particle, which is explained by whom? Stokes' law, right? Reduction in the size of particles can be achieved by processing such as milling, sieving, and grinding. These processes reduces the size of a particle. Particle size also affects rate and extent of absorption, which is also called what? Bioavailability, right? We all know now bioavailability is what? Rate and extent of absorption. And particle size also affects the dissolution rate and biodistribution of the drug. However, reducing particle size beyond a certain limit may lead to formation of a compact cake upon sedimentation. Now, viscosity of the dispersion medium um, is also an important consideration in formulation of suspension. Now, if viscosity is greater of any dispersion medium, that offers the great advantage of slower sedimentation. If a material or if a suspension is viscous, it means it is thicker. So the sedimentation of the particle will be very slow. However, it may comprises other desirable properties such as syringeability for parental suspension. If viscosity gets higher, then syringeability is a difficult step, you know. Spreadability for topical suspension is also typical note if the viscosity gets higher, and ease of administration for oral suspension also. The property of shear thinning is highly desirable so that the suspension is highly viscous during storage when minimal shear is present so that the sedimentation is slow and has low viscosity after agitation. Agitation is what? We are mixing in harsher mixture with high speed to facilitate ease of pouring from the bottle, right? Now, interfacial properties of the suspended particle are in which pharmaceutical suspension, the solid phase remains as finely divided particles in the dispersion medium. Therefore, a large amount of interface is involved in the formation, which in turn affect the stability of suspension. The interfacial properties therefore play a vital role in modifying the physical characteristics of dispersion. The two most important interfacial properties include surface free energy and surface potential. A large surface area offered by finely divided solid materials is typically associated with large amount of free energy on the surface. System with very fine particles is thermodynamically unstable because of high total surface area. The system thus tends to agglomerate in order to reduce the surface area and thereby the excess free energy. Surface free energy may also be reduced to avoid the agglomeration of particles, which can be accomplished by reducing interfacial energy. And how we reduce interfacial energy? When a wetting agent is added to the suspension formulation, it is absorbed at this interface. This will result in a reduction of the interfacial tension, making the system more stable. If interfacial tension is more, then the system can't be stable. If it will, and what a wetting agent will do? It will reduce the interfacial tension and make this suspension more stable. Surface potential exists when dispersed solid particles in a suspension possess charge in relation to their surrounding liquid medium. Solid particles may become charged through different ways if the suspension contains electrolytes. Selective absorption of particular ionic species by solid particles is a possibility. This will lead to the formation of charged particles. Now, there are various types of suspension which we are previously discussed, right? So that's it for this lecture. So thank you very much. If you have any queries, then you can contact or you can comment below. And if what you learn about this lesson, please let me know. Make some short notes about this lecture. Okay. Thank you. Thank you so much for your cooperation. Thank you.